This is part 2 of lesson 7-4, all on parallel lines and proportional parts. So in video 1, we just talked about triangles and a triangle with a base and a line parallel to the base and how those two parallel lines separate the legs into proportional parts. So we're basically doing the exact same thing, but we're not limiting ourselves to just triangles now, okay? So this is just saying that whenever you have parallel lines, here we have 1, 2, 3 parallel lines. Here I can highlight them so we can not get confused. 1, 2, 3. Those 3 parallel lines separate sections of transversals into proportional parts. So what this is saying is if these 3 lines are parallel, then the relationship between these 2 sections from this transversal are going to be the same as the relationship between these 2 sections of this completely different transversal. It's going in a kind of a different direction, right? They're not the same, but they are both being sliced by these parallel lines. So since the parallel lines are slicing them at the same rate, right? This parallel line is slicing this line at the same rate that it's slicing this line. Same with this one, same with this one. That means these sections, like I said, are proportional. Okay, so A over B is the same as C over D. Same thing over here. We've got these 3 parallel lines. There's a lot of lines going on, so sometimes in your brain it gets hard to keep track of them. That's why I highlight. These 3 lines are parallel. These guys that aren't highlighted are transversals. And these parallel lines cut the transversals in proportional parts. So U to V has the same relationship as W to X. In other words, if U was, we'll use the same numbers as last time, U is 2 and V is 3, then W and X might be 4 and 6, right? So even though the numbers are different, their proportions are the same because 2 to 3 is equal to 4 over 6, right? 2/3 and 4/6 are the same thing. If we simplified 4/6, we would get 2/3. If I cross multiplied, 2 times 6 is 12, 3 times 4 is 12. They're equal. These are 2 equal fractions. Even though the numbers are different, the fractions, the ratios are the same, okay? And then the one little exception here is that if one of the ratios is equal to 1, right? And what 2 numbers, what over what, would be equal to 1? What kind of fraction, what numbers are in a fraction to make the fraction equal to 1? It's whenever the number on top and on bottom are the same. So like 3 over 3 would be equal to 1. 7 over 7 would be equal to 1, right? So if this is equal to 1, so the numbers are the same, it means these 2 things are congruent. So it basically means this line segment in this little area here got cut in half, right? So it would mean that this line segment in this little area also got cut in half. Whatever happens with this line by these parallel lines also happens to this transversal the same way. Okay, so if one of the ratios is equal to 1, it means these are congruent parts. So the other transversal also gets congruent parts. Okay, it's just all proportional. So let's do some examples here. Just jump right to the bottom. We've got 6 again. So here, I'll zoom in a little bit. Yeah, that'll make it easier. All right, so find X and Y. We're solving for both. In this first one, we only have X's, right? So the ratio, first of all, let's figure out what are my parallel lines, right? Here, here, and here. So the ratio of the transversal sections are the same. So whether I'm talking about this to this or this to this, it's the same ratio. So 5x and 3x have the same relationship as x plus 12 and 12. And then once you have it set up, the setting up part is the geometry, and then solving, that's just your algebra, right? Knowing the rules, the geometric rules, helps us set up the problem, and then solving the problem is just algebra. So we're going to cross multiply. I'm actually going to end up with a quadratic here, which I don't want. One thing I'm going to do, if I multiply x by x, I'm going to get an x squared, and I don't want that. So can I simplify either one of these? Well, I can't simplify this side, but is there anything I can divide both of these by? Yeah, x, right? I can actually get rid of both of the x's here. I can't divide the top and the bottom by 5. I can't divide the top and the bottom by 3. But I can divide the top and the bottom by x. These x's just cancel each other out. So I end up with 5/3 equals x plus 12 over 12. So when I cross multiply, 5 times 12 is 60. And 3 times x plus 12 gives me 3x plus 36. Okay, and then I can keep solving. So minus 36 on both sides. That's 24 equals 3x. Divide by 3, and x is going to equal 8, right? None of these problems should give you quadratics. We're not in quadratics. A quadratic is when you have an x squared term. So if you end up with that, go back and see if you can simplify anywhere. Like here, we could simplify. We could actually cancel out this x, and then we don't end up with any x squared. Okay, number 2. Where are my parallel lines, and how can I write this out? Okay, so here to here to here. These are my parallel lines. And so if this transversal is separated into congruent parts, that means this transversal also has to be separated into congruent parts. Because these lines cutting through them are all parallel, whatever happens to this line, this line, the same thing happens, right? We might not end up with the same numbers, but it's the same proportion. Okay, so 12 is equal to 2x minus 6, and it's also equal to x plus 13 because all these sections have to be equal to 12, right? So 2x minus 6 equals 12. Add 6 to both sides. 2x equals 18, so x equals 9, which means this guy down here should equal 12. 9 plus 3, is that equal to 12? Yes, it is. So x equals 9, that works. Since these guys are all equal and they're marked congruent, that means these 3 all have to be equal as well. That's how I solved for x. All right, number 3. All right, we've got to mark off our parallel line here, here, and here, which means the relationship between this guy and this guy is the same thing as this guy and this guy. What else do I know? Well, these are marked congruent, so I can set these equal to each other, right? And if these are congruent, that means these have to be congruent. So to solve for y, I'm going to set 3y equal to 2y plus 2 minus y from both sides. Y equals 2. And then to solve for x, I set them equal. 2x plus 4 equals 3x minus 1 minus 2x from both sides. 4 equals x minus 1. Add 1 to both sides, and I get 5 equals x, or x equals 5. I didn't do it up top, but you really should always put your variable first before you're done. I didn't flip-flop it here, but I should have. Okay, number 4. Mark off your parallel lines. You don't have to, I guess, if you're really good at keeping it all straight in your brain. I don't even want to try. I just go ahead and mark them off so I don't get confused. Okay, and so the relationship between this guy to this guy is the same as this to this. And don't get confused. You don't have to say 5 to 8. You could say 8 to 5. But however you look at this side, you have to look at this side the same way. So if I said 5 to 8, if I do this part on top and this part on bottom, then over here I have to do this part on top and this part on bottom. They have to correspond. Okay, so I'm going to say 5 over 8 equal, I'm going to use my black pen, not my purple, it's fading, equals y over y plus 2. And then I can cross multiply. So I get 8y equals 5 times y plus 5 times 2. Oops. And then I can just solve algebraically. Get rid of my smallest y, minus 5y on both sides. 3y equals 10. It's kind of a weird one. And then divide by 3. So y equals, you can either leave it as 10/3 or you can say 3 1/3. That works as well. Yeah, because 5/8 is a weird fraction. Y plus 2. Yeah, I did that right. I'm just double checking my math. All right, and then number 5. Okay, again, mark off your parallel lines. And then it's easy to see your sections. So this line is going to have the same proportion as this line. So little over big is going to be equal to little over big. So I'm going to write 3 over x is equal to 4 over x plus 4. And once I know how to set it up, then it's just algebra to solve. X times 4 is 4x. 3 times x plus 4. 3 times x plus 3 times 4. Get rid of my smallest x, minus 3x from both sides, and x equals 12. Okay, and then last one, number 6. I'm going to mark off my parallel lines. This guy, this guy, this guy. And so the relationship between this and this is the same as this and this. Okay, so what I see is 16 and 32. I know 16 is half of 32. So this is going to be half of this, but that doesn't really help me solve to know that y is half of y plus 3, right? So I'm going to go ahead and write it out. 16 to 32 is the same as y to y plus 3. Cross multiply. 32y equals 16y plus 30 and 18 is 48. I'll give you a little trick too. Remember over here for this top one, how we got rid of this x to simplify? Down here, if you don't want to deal with such big numbers, you can simplify this into just 1/2. 16 over 32 is the same as 1 over 2, right? So that when you cross multiply, it's a lot smaller numbers. Let's actually go ahead and do that. We'll get the same answer. Let's go ahead and do that. Just because I don't have a calculator in front of me. So this is the same as 1/2. So 1 times y plus 3 gives me y plus 3. And 2 times y gives me 2y. Minus y on both sides. So I get 3 equals y, or y equals 3. That's a lot quicker than doing 32y equals 16y plus 48, right? We'd get down to this eventually, but it's easier when you simplify first. Okay, let me know if you have questions.